In this video, we're going to look at different ways that we can compare fractions and tell which one is greater than or less than another fraction. When fractions have the same denominator, it becomes rather easy to tell which one is largest. All we truly have to do to tell us which one is largest from 3/9 and 7/9 is to look at the numerator. Which numerator is largest? Well, 7/9, 7 is larger than 3, so 7/9 must be larger. Another method would be to draw out these fractions artistically. In purple, I'll represent the fraction 3/9, and in red, I'll represent the fraction of 7/9. I notice that each fraction has a denominator of 9, so each candy bar we will divide into 9 equal pieces. In the fraction 3/9, the numerator is 3, telling us that we need to shade in 3 of our 9 pieces of candy. Similarly, in our fraction 7/9, we need to shade in 7 pieces because our numerator is 7. So 7/9 of the candy bar is shaded in. And now very clearly we have a visual representation of why 7/9 is greater than 3/9. Again, when fractions have the same denominator, our quickest way to tell which fraction is greater is to simply look at the numerator. For instance, here in 2/3 being compared to 1/3, we can take a look at the numerator and quickly see that 2/3 is going to be greater. But we can also again draw out a picture to visually represent each fraction. Here I've drawn a circle and divided into 3 slices, and again another circle dividing into 3 slices. In the fraction 2/3, we can go ahead and shade in 2 of our 3 pieces, showing 2/3 of the region being shaded. And likewise, with 1/3, we'll take our green circle and shade in 1 of our regions. Here it is very easy to see that 2/3 is greater than 1/3. But what happens when your fractions have different denominators? Sometimes, when our fractions have different denominators, it becomes difficult for us to compare the fractions and quickly tell which one is greater or less than another fraction. Let's compare 3/8 to 1/5. One of the most basic methods of comparing fractions is to do so visually. So we can attempt to draw a picture of a circle with 8 equal pieces and shade in 3 of those sections. Similarly, we can draw a circle that has been divided into 5 equal pieces and shade in 1. And we can ask ourselves, which circle has more regions shaded in? It appears that 3/8 is greater than 1/5, but there's another method that we can use besides illustrations that will be more accurate and faster, especially when our denominators grow quite large. In this strategy, we are searching for a common denominator through the process of prime factorization. And prime factorization is quite an intimidating name, but it can help us to find a common denominator for our 2 fractions. First, we ask ourselves, what are 2 factors of 8? Well, 2 factors of 8 are 2 and 4. 2 is a prime number, so we'll circle that. And the 2 factors of 4 are 2 and 2, and both of those are prime. So what we really have is 2 times 2 times 2. Next, what's the prime factorization of 5? Well, 5 actually, it's a prime number. So we can take that 5 and multiply it times these 3 2's. So 2 times 2, that's 4, times 2, that's 8, times 5, that's 40. And this is what we were really searching for. We were searching for a common denominator for these 2 fractions. And our common denominator is going to be 40. So our first fraction of 3/8, we need to multiply it by something. Multiply the numerator and the denominator by some number. So we have a fraction with a denominator of 40. So we ask ourselves, 8 times what? 8 times what is 40? Well, I know that 8 times 5, that is 40. And whatever I multiply my denominator by, I have to multiply my numerator by. So 3 times 5, that's 15. And now I've made an equivalent fraction. 5/40 is equivalent to 3/8. Now let's take our second fraction, 1/5. And again, we want to multiply the numerator and the denominator by some number to get a fraction with the denominator of 40. We ask ourselves, 5 times what is 40? We know 5 times 8 is 40. And if we multiply the denominator by 8, we multiply the numerator by 8. So we get 8/40. So 8/40 is equivalent to 1/5. Now we have two fractions with the denominator of 40. And we can look quickly at each one. 15/40 and 8/40. And because 15 is larger than 8, we know that 15/40 is greater than 8/40. In much the same way, we know that 3/8 is greater than 1/5, because 15/40 is equivalent to 3/8. So we can go ahead and fill this in. 3/8 is greater than 1/5. Let's take a look at another problem that will ask us to compare two fractions. In this problem, we're given 7/12, and we need to compare that to the fraction of 2/6. In this problem, I won't bother taking the time to do the prime factorization, because when I look at 7/12, I notice that the denominator of 12, well, I can manipulate this fraction of 2/6 in a way that's going to create an equivalent fraction with the denominator of 12. Because I know that 6 times 2 is 12. And if I multiply my denominator by 2, I have to do that to the numerator. 2 times 2 is 4. So now I've created an equivalent fraction. 4/12 is the exact same thing as that 2/6 used to be. But the beautiful thing about it is that I've changed 2/6 to become a fraction with a denominator of 12. And now it's easy to compare this numerator of 7 to this numerator of 4. They both share the denominator of 12, so I can easily tell you that 7/12 is greater than 4/12. Hopefully this video has helped you understand the benefits of making illustrations as well as finding common denominators when comparing fractions. Thanks for watching.